Hello, friends, and welcome to another episode of Conversations at the Intersection of Cutting-Edge Science and Spirituality. I am Jennifer Cahill, and I'm so grateful to be continuing this journey with you. Here we are 3 years later after our initial inquiry and deep dive into this topic at a live UC Irvine event. And as always, we have my two esteemed colleagues here, Dr. Deepak Chopra, author of 90 books, including his most recent book, Live in the Light, and the man that Time has called one of the 100 most inspiring and influential people of the last century. And of course, we have Dr. Donald D. Hoffman, who has his PhD from MIT and is the author of the best-selling book, The Case Against Reality: Why Evolution Hid the Truth from Our Eyes. Don, in addition to being a best-selling author, has authored numerous papers, including one that we are going to be discussing today. And I thought, what better way to start today's conversation than to read you the first line of Don's new paper. Space-time is doomed. It is not fundamental reality, nor are its objects. And with that, Don begins to build a new thesis and a new theory for what is fundamental reality. If space-time is doomed, what then can potentially replace it? So as Don highlights for us in the paper, his theory ties in the idea of conscious agents, which are elements of consciousness that are beyond space-time. They have no size, and they are timeless because they occur prior to space-time. So Don, I would love it if you could start today's discussion for us by giving us a little pull behind the curtain of what it's going to mean for us as human beings if we move into this theory of conscious agents that you have purported in this paper.
Right. So what's surprising is that physicists themselves are the ones who are telling us that space-time is not fundamental. And they're using their theories of quantum field theory and so forth to actually prove this. So these are theories that assume that space-time is fundamental, but using those theories, which assume that space-time is fundamental, the theories themselves point to their own limitations of their key concepts. That's the way science works. You start with a theory that assumes something, but because it's mathematically precise, you find out the limits of that. So the limits are that space-time itself ceases to have any operational meaning at the so-called Planck scale, 10 to the minus 33 centimeters and 10 to the minus 43 seconds. And so the race is on among physicists to find out what's beyond space-time. What are these deeper structures? What are the deeper symmetries and so forth? And they're finding wonderful new structures like amplitude-hedron and cosmological polytopes and EFT hedrons and decorated permutations. So it's so I'm a Johnny-come-lately to this. I mean, the physicists they're the ones, not me, that said space-time is doomed. They're the ones that are finding the initial structures. And what I'm trying to do with my team is to show that we can give a dynamical interpretation of these structures. Right now, they're only finding these static structures, but we have this theory of conscious agents, which is a Markovian dynamics, and we've been able to show how that links into the structures that they're finding, in particular decorated permutations. And so this means that we're about to enter an era in science in which we have a dynamics of entities outside of space-time as the fundamental building block of our science. And so that's going to be, even if you don't believe in consciousness, the question is going to be, what are these entities beyond space-time whose dynamics is giving rise through projection to space-time and all the things that we see inside space-time? Now, in terms of your question, Jennifer, the implications of this are, of course, tremendous. Every time we've made a huge advance in science, like the discovery of relativity theory, the discovery of quantum theory, it's not been too long before new technology comes out of it that changes the game completely. So when we start dealing with the science of things beyond space-time, it's going to allow technologies that are going to be completely mind-boggling. We won't have to go through space-time. We can go around space-time, and that's going to be wild.
I am so blown away by that, Don. As I was reading the article, I was texting Don fervently. I was like, Don, when can I share this article? This is the best thing you've ever written. And the reason it's such a compelling paper, Don, is that what you're proposing is something that our minds can't even fathom, given that I like to think of space-time as our safety blanket. You know how a little kid might have their little bunny or their safety blanket? For millennia, for as long as human beings have been alive, since Newtonian physics, special relativity, space-time has been our safety blanket. And I almost feel that there has to be an ease into it as we ease into what lies beyond this, to jump into quantum computing, quantum communication, what this means for the future, which really ties into probably, Deepak, your next book, which could be Quantum Consciousness. I'm giving it to you right now. There's your new title if you'd like it. So Deepak, what are your thoughts on
Actually,
quantum?
the next book is done, and it's
Of
not
course
called
it is.
it's not called Quantum Consciousness. It's called Quantum Body, and it's with the quantum physicist Jack Tuzinski and another neuroendocrinologist by the name of Brian Fertig. Brian is a professor in New Jersey. Jack is a professor in many places, including Europe, Poland, Canada, and many others. And I've known these guys for a long time. Perhaps, Don, you've met Jack anyway at the Science of Consciousness.
Probably, I don't recall,
But let me take what Don said because I'm still trying to comprehend what he said. And you mentioned these structures which are not dynamic, and then you went on to speak about dynamic structures. I guess they're mathematical structures, right? They're mathematical structures,
for example,
not
geometric, right?
geometric structures. So, and then you go on to talk about the dynamic structures that evolve as a result of this. Correct?
Or that evolve prior to these structures. So the static structures that the physicists have found are in some sense a projection of a deeper dynamics.
I see. So, you know, a while back I was doing a conversation on this same forum, same platform, on my YouTube channel, and I was speaking to Wilczek, the Nobel laureate from MIT, who's written a book called Fundamentals. And in the book, he has a chapter called Fundamentals of Fundamentals. And he described the fundamentals of fundamentals as three entities: spin, charge, and mass. Then he went on to say that these do not actually have, they're not physical. They're non-physical, spin, charge, and mass. And yet they drive all of the evolution of the appearance of the universe at a very fundamental level. Does spin, charge, and mass play a role? Because, you know, in Eastern philosophical traditions, Vedanta, Advaita, there are three things that are entities which are very similar to spin, charge, and mass. So one is called sattva, which is the creative force, the movement. And then there's rajas, which is transformation or charge. And then there's tamas, which is inertia. Do these structures have anything to do with these entities?
Yes, I will say first that these new structures beyond space-time that the physicists are talking about are actually deeper than quantum theory. So quantum theory, they anticipate, for example, Nima Arkhani Hamed at Institute for Advanced Study at Princeton is saying that what he anticipates will happen is that space-time and quantum theory will arise together as mere projections. So quantum theory is not more fundamental. It's actually merely a projection of a much deeper dynamics beyond space-time. And the weirdness of quantum theory, you know, the needing superpositions and so forth, is really just an artifact of the projection process. It's the fact that it's not the deepest theory that it has all these weird properties. When we go to a deeper theory, we'll see how quantum theory arises from it. But in the paper that we're going to have released in June, middle of June, yes, the dynamics of conscious agents that we have there, we have specific proposals about how mass arises as the so-called entropy rate, of the recurrent classes of the Markovian dynamics. So the recurrent communicating classes. The entropy rate corresponds to the mass. The action of the Markovian kernel as an operator it turns out to have connection with spin. So we actually propose how spin 0, half, and 1. So we don't go to 3 halves and 2. And there's right now no concrete evidence that 3 halves and 2, there are no particles that have been discovered yet with 3 halves and 2. But for 0, half, and 1, we have a concrete proposal about how the Markovian kernel acting on an orthogonal set of basis vectors and the way it manipulates them. We use geometric algebra to get spin coming out of it, spin 0, half, and 1. And we also are going after things like bound versus free particles and confined particles from so notions of charge and binding and so forth are going to come from this as well. And those are all spelled out as proposals in this new paper. And so they're mathematically precise. So we don't have to wave our hands. We'll find out whether they work or not. They're mathematically, there is no wiggle room here. We're either right or we're wrong, and we'll see.
And so has the experiment already taken place, Don? I know you propose in great depth in this beautiful 36-page paper, the full breadth of the computational experiment you intend to create. Has it been done yet, or what is your anticipation of when this will be complete?
It's going to take, so the proposed experiment is that we have this mathematical Markovian model of conscious agents, and we want to show how to model the dynamics of the interior of the proton. So the quarks and gluons and so forth, and what they're doing inside the proton. There's been studies for the last 40 or 50 years using high energy colliders, electron ion colliders and so forth, electron proton colliders, that have discovered the momentum distributions at different values of what they call Q squared, which is the energy that you're using, and Bjork and X, which is roughly the temporal resolution that you're using to study. And so you get different distributions of quarks and gluons inside the proton when you look. And so our proposal is to start with the theory of conscious agents and have a computational simulation where we find the right parameters for the Markovian dynamics of conscious agents that gives us the precise momentum distributions that have been found in these experiments. In other words, we're no time for hand wave now. We want to actually go and show, can we find parameters of this dynamics of conscious agents that gives us the exact, in this case right now, one-dimensional momentum distributions. New experiments are going to be giving three-dimensional. We want to model those when those are available, but those aren't available right now. We can predict them, by the way. We could predict them from these experiments, but the computations involved in this are more than I have. So I've been doing little things, that I can do on my laptop. I've got a nice laptop, but we will need supercomputers to actually to deal with this. Even if you have only say 1,000 states in your Markov chain, only 1,000 states, just to write down one matrix is 1 million entries. And now to start operating, and 1,000 states is pretty small. So we might need simulations with 1 million states, in which case there are going to be, it's a huge number of states just in the matrix. So you can see this thing blows up pretty quickly. No, I haven't done, I've done proof of concept simulations, which are very, very encouraging. But the proposal is to eventually get a team that has serious compute power to do this.
So I have a question, Don. For the average person who's looking at this conversation or listening to it, Markovian dynamics is a kind of an intimidating term. Okay. I was looking it up after I saw your paper. So
Same.
It seemed to suggest that Markovian dynamics is the evolution of a system which is memory-less or something like that. Can you explain that? And also, in that same context, this last year's Nobel Prize was all about entanglement and non-local correlations. And, many years ago, almost 20 years ago, actually, I met a neuroscientist, physicist in the Netherlands, who used the word acausal, non-local, quantum mechanical interrelatedness, which sounds very similar to this whole idea of non-local correlation or entanglement or inseparability of events that actually encompass a whole. In other words, there are no such thing as parts. There's only movement, and what we call a part is just a artifact of observation.
Absolutely. So on the notion of Markov chains and Markov dynamics, it's typically called a dynamics that's memoryless, that what happens at the next step of your dynamics doesn't depend on anything except your current state. Now, people might say, well, that sounds, if it's memoryless, I mean, that sounds very, very limiting. What it is not really limiting. It's not truly speaking completely memoryless, right? It does remember the current state, and it's using that for the next state. But you can make the current state as big as you want. So what it really means is it's got a finite memory, as big as you want, as long a memory as you want, but finite. And so they're pretty general. They're pretty general systems, and they're well studied. So now, in terms of the other thing that you mentioned, the Nobel Prize was given for showing empirically that the prediction of quantum theory, that local realism is false, that prediction is correct. So local realism is the claim that particles, for example, or physical objects in general, have no definite values of their properties like position, momentum, and spin when they're not observed. That's the realism. So realism is the claim that they do have those properties, and the denial of realism would be the claim that they don't. And locality is the statement from Einstein's theory that properties in space-time have influences that don't propagate faster than the speed of light. So local realism is the two together. It's the claim that physical objects do have those physical properties like position, momentum, spin, and that they have influences that propagate no faster than light. So the denial of local realism is the denial of that whole package. Now that means that you could, for example, just deny the locality part and keep the realism part, right? Or you could keep the realism and deny the locality, or you can deny both. No. So my take is that both parts are false. But what's been proven experimentally, or at least shown very, very strongly, strong enough to get a Nobel Prize experimentally, is that the package is false. The local realism is dead. And quantum mechanics does predict that. So now people are scrambling. Can we keep realism? Do we have to? No one really wants to give up locality, but we have entanglement, as you said. Now there's entanglement. But now what happens is if we just bite the bullet and say local realism, both parts are dead. Locality and realism are dead. We need to do what many physicists are doing now, which is to say, let's find new structures behind space-time, which project into space-time and give us the physics inside space-time, named quantum field theory, that actually give us quantum field theory in space-time, but from structures entirely beyond space-time. And so when we do that, then of course what we're dealing with are structures which are non-local by definition. They have nothing to do with space-time. They're prior to space-time, so they're completely non-local. But they're also prior to quantum theory. So that's why quantum is not going to be the fundamental thing. It's not like space-time is secondary to quantum theory, which is the deep thing. No, it's rather that space-time and quantum theory themselves are, in some sense, trivial projections of a much deeper realm that's beyond quantum theory and space-time.
Jennifer, you have a question, but I have a follow-up question, but go ahead.
Yeah, I just wanted to share something. Like you, Deepak, I was researching Markovian kernels and trace chains, among other things, after reading Don's paper. And there was one excerpt of a gentleman who was interpreting some of Don's work that I found to be helpful to better explain. And I would love your take on this, Don, to see if it's accurate for what we could potentially do with conscious agents and understanding it. In this quote, he says, "This perspective provides," meaning your perspective, "provides an alternative explanation for the seemingly instantaneous communication observed between entangled particles, as the shared conscious agents may enable a direct connection between the particles that exist outside the constraints of space-time." Would that be fairly accurate, Don?
Absolutely. That's sort of the idea, is that these conscious agents are not bound inside space-time. Space-time is merely a trivial interface that some agents use for their interaction with other agents. So it is just a data structure. Space-time is a data structure, a headset, if you will, or a desktop interface, for a laptop that some agents use to interact. And so since they're not confined to that interface, the things that they're doing are entirely non-local. And so you could have what look like instantaneous connections inside space-time because they're completely not bound to the space-time. So the idea is that you and I, we are not little entities inside space-time. We are the authors of space-time. Space-time itself is a data structure that we create, quote, so to speak, in our heads. It's just an interface that we use, but we transcend that interface.
Let me ask you a follow-up question, which is much simpler. What you're saying is ultimately there's no such thing as, and let me finish my question before you answer it. You're saying that there's no such thing as matter, because all of science as we know it right now is based on the assumption of matter as an ontological principle, as in matter as the ontological primitive, whatever you want to call it. Okay, everything that we do assumes the existence of matter, and of course in the theater of space-time and causality. Now there's an Eastern meditative exercise which says, look at any object, including your own body, your hand, and replace the word object with the word experience. Just replace the word object, material object, with the word experience, because in order to even call it an object, I have to experience it first. And then if I ask myself, what is the experience? Then that experience becomes a perceptual activity. This is a perceptual activity. So is the body a perceptual activity. So is the brain a perceptual activity. And that perceptual activity is a modification of a fundamental, formless, borderless, infinite, incomprehensible, acausal entity that is unimaginable, but is modifying itself into both perception and cognition, which gives us the idea of matter. And, we can then go even further, that say that if matter is an idea, it's almost Platonic, then even subatomic particles and molecules and brain and body are just ideas.
Well, I would certainly agree that when we say that local realism is false, and when I then say that I think that both parts are false, locality and realism are false, then that means that those particles don't have any values of position, momentum, spin, anything when they're not observed. And if you don't have a position, you're not there. And so these particles aren't there when they're not observed. They're actually what we create. As you say, they're experiences that we create on the fly. And I think a good analogy of this is like in virtual reality. If you have a virtual reality headset on and you're playing a video game, say, Grand Theft Auto in VR, and I look over and I see a red Ferrari. Well, that red Ferrari exists only as my experience when I look in the right direction. And as soon as I look over here, and I see a green Camaro, the red Ferrari doesn't exist anymore. There's no red Ferrari in the supercomputer.
But the eye that is looking is not the mind or the brain. The eye that is looking is transcendent, acausal, non-local entity. Does it have any individuality at all?
Well, so I absolutely agree that this entity, the entity that's doing the observing, is not something inside space-time. So it's not your physical eye, it's not your physical brain. These are all just symbols inside of space-time. So we have to think outside the box. And see, physicists are already doing that. Physicists are going outside the box. They've got the amplituhedron and decorated permutations. So you can do it. You can actually go there rigorously and find these structures beyond. But you have a very good point there, Deepak, that this thing that's beyond space-time. From spiritual traditions, right, there's just the one, and any division of the one into parts is a projection. It's not the full one. And our theory of conscious agents agrees completely. And I was surprised because I started with a finite, our team started with a finite definition of conscious agents, because, you know, you have to write it down, you have to be able to, but it turned out to be a theorem that any group of conscious agents was also a conscious agent. They were one conscious agent, which means is the theorem of our theory that there is ultimately just one ultimate conscious agent. But that one conscious agent cannot be described even using the mathematics of our theory, because, and I'll just explain why. It's pretty, and so this is sort of a mathematical underpinning to what the spiritual traditions have been saying for centuries. Suppose I have a countable infinity of these conscious agents. So I can then remember 1, 2, 3, 4, 5, all the way to infinity. So that's a big number, right? That's a huge number of agents. Well, any possible subset of them, like agents 1, 2, and 3, they form an agent. 25, 90, and 72, they form an agent. Any subset. So that the set of all possible subsets is called the power set. So if you have this countable infinity of conscious agents, then there's a power set of new agents from all the possible combinations. It turns out the power set is a bigger infinity. So there's not just one infinity. So the countable one, 1, 2, 3, 4, 5, up to infinity, that's the smallest infinity. We call it Aleph 0. But the next step up,
are the conscious agents entangled?
From the space-time point of view, absolutely. Absolutely. And in fact, they're interacting entirely outside of space-time. So in that sense, they're completely entangled. But now you have an Aleph 1 infinity, and then we look at their power set, Aleph 2. And so you go, there's an infinite number. This is called Cantor's hierarchy. And so the one is going to be, if we go from Aleph 1 to Aleph 2, Aleph 3, all the way through Aleph infinity, which there isn't any. You never end. So what that means is that spiritual traditions are right from the point of view of conscious agent theory. There is one ultimate consciousness, and our mathematics can never get there. It can point to it, it can say, it can prove that it exists, but it cannot describe it. So I can only describe projections of it. And then from those projections, we can then get projections into space-time. So yes, I was stunned. I didn't plan it this way, but I was stunned when this mathematics lined up with what spiritual traditions have been saying for a long time. So what I think here is we now have we're getting to the point where there'll be a language in which the spiritual traditions can start to state their ideas even more precisely. And we can start to now have science and spirituality have a really good language of communication.
So there's a phrase in the Yoga Vashishta, very very poetic. It says, infinite universes come and go in the vast expanse of consciousness, like motes of dust dancing in a beam of light. So does this lead to the idea of infinite universes, multiverse as well?
That's right, where you have to get an even bigger notion of infinity than most people have ever had, because there's not just one infinity, there's an infinity of ever bigger infinities. And this is saying that we have to think about the furthest, biggest infinity if we're going to talk about the one. And so there's dances at all these different levels of infinity. So this, you can see, it really enriches the statement of the spiritual tradition, because it brings in all these levels of infinity into the picture. So it makes it even, in some sense, it even hits more deeply to me how profoundly infinite the one is.
Yeah, if I may piggyback on that, Don, since we last spoke last year, I was on my way to Giverny. I was in the back of a car and I was doing just a normal meditation. It was this one on chakra balancing. And all of a sudden I got to the third eye. And I don't know if either, I'm sure Deepak has had this, I'm sure you may have it as well, Don. But I'm sitting there and I get to the third eye and I just dropped out of space time. I was gone. It wasn't there anymore. And I was shown this image. And it was to the point of what you were just discussing, Don, and what Deepak referenced. I was shown billions, infinite amounts of light. But instead of moving away from one another, instead of expanding outwards towards the universe, I saw that they were all infinitely moving back towards the singularity, towards the original light, which was all of our souls, if you wanted to call it a soul from a spiritual standpoint. And then, of course, my husband tries to like get my attention because of beautiful fields, and I get bounced back into my body. And about 4 hours later, worst moment of the life, I was like, you don't know, I was just getting space time, and the universe explained to me. But what was fascinating was a few hours later, I was walking in Paris near the Louvre. And in that moment, I dropped back into that state. And in that moment, though, every person that I saw, the women, the children, the old people, the young people, became the sparks of light. And I felt at the same time the crushing loneliness that every human being has ever felt at being separated from one another, and the sublime joy at knowing that we're all one and that we're just re-remembering it. And it was one of the most profound moments of my life. And I just share that because it goes back, I think it was Teilhard de Chardin, who was a French philosopher, ironically, who had this idea that over time, all separate entities would converge, creating a state of ultimate unity, which it sounds like is what your theory is getting to, Don, right?
It's saying precisely that there is this one infinite fundamental unity. And so even like the computational simulation that I'm proposing, the master matrix that I'm going to use for the Markovian is going to be a trivial projection, right? Mm-hmm. I can't start with the one that's just, you can't do it. So I have to start with my surrogate, which is going to be a trivial thing, even if it's a million by million matrix. That's nothing compared to Aleph infinity. So, but that's what we're going to have to do to try to simulate what we see inside space-time. So that, yeah, there's a deep, deep unity, and we all are just different projections of that one, looking at itself through different filters.
But, you know, a very strict orthodox non-dualist would say that Jennifer's experience, profound as it was, is still a symbolic representation of the incomprehensible. As long as you can describe it, it's a symbolic representation, and therefore the one singularity, whatever we want to call it, is non-symbolic and therefore totally incomprehensible.
Yeah, so I agreed, and that means even my mathematical theory is itself just. But of course, the interesting thing is that even in spiritual traditions, we don't stop talking. We still talk. So the question then becomes not whether we're going to talk or not. I mean, of course, I would certainly respect a guru who says no more. I'm not going to, no concepts, I'm not going to talk anymore. I would certainly respect that. But if we're going to talk, then science offers this mathematical precision in language. Like, for example, instead of just talking about the infinite, how about Aleph 0, Aleph 1, Aleph 2 through Aleph infinity? Now we have this whole range of notions of infinity that we can use. So we get this more precise language. So if we're going to talk at all, why not talk precisely? And there does seem to be some reward that we get from that precision, right? Before we had Newton, we couldn't do many, many things. Now, after Newton, we had all sorts of science and technology that we could do. And, you know, then with quantum theory, we got all sorts of new, we're able to do new things. Even though the story that we have is not the final story, we are rewarded for being precise. Part of the reward, though, is finding out precisely the limits of our current theory. Right? If we're not being precise, then we can be dogmatic because we can't ever see the limits of our own stuff. And so it's very easy to say, I'm right. Whereas, you know, for example, with as I mentioned earlier, the theories of space-time are so precise that they come back and say space-time can't be fundamental. Now, there you have the anti-dogmatic nature of the precision of science, that you start with certain fundamental assumptions in the theory, But because you're precise, the theory itself, without self-contradiction, tells you the limits of those basic concepts, and then says, okay, ultimately, you're going to need a deeper set of concepts, which will have their own limits, and so forth, in an endless virtual cycle of deeper and deeper, more precise theories. And that's what I hope to see in science and spirituality. Is
Right
that
now, the prevailing conversation in the zeitgeist, three things are definitely there. One is virtual reality. And what you're saying is we are already in a virtual reality,
Right.
number one. Second is artificial intelligence, and how that is going to impact the future of human civilization, divine or diabolical or something in between.
Right.
And the third is quantum computing. And these three disciplines, artificial intelligence, quantum computing, and VR, if they come together in a super intelligent combination of technologies, is radically going to change the world we live in.
I think so. I think that when we get a science of the entities beyond space-time, and we get a mathematically precise theory of it, I envision technologies that are completely mind-boggling. So, for example, right now, most of the galaxies that we see, we could never get to. Even traveling at the speed of light, we couldn't get there because space itself can expand faster than the speed of light. And so we can never get, so there's all this real estate out there that we can never get to, but it's waving at us saying, hi, we're here, and you could never come, you can never come visit us. And even for the stuff that we can get to, like the Andromeda galaxy, which is, I don't know, 4 or 5 million light years away from us, something like that. Yeah, I'm not going to get there. My grandkids on the spaceship aren't going to get there. It's going to be great, who knows how many great before we get to, that's if you go through space-time. But if we have technology that's outside of space-time, what if we just decide, space is just our headset. I don't need to go through space-time. I can go around. I'll just go directly to Andromeda around space-time directly. We won't need to use rockets and all this fuel. We'll just figure out technologies that just get you there. So that's the kind of thing that that I see as a mind-boggling potential. The technologies that just allow you to go outside the headset and go wherever you want.
Will this new combination of theories address things like dark matter, dark energy?
I'm hoping that, and I have some ideas myself about how the proposal we have will lead to notions of dark matter and dark energy. At top level, you can sort of see how it's going to happen. If space-time is some set of information losing projection of a much deeper dynamics, there's no surprise that there's all sorts of stuff going on out there that you don't see inside space-time in the particles that you actually can see. And those are going to be things that are dark to what you can see inside space-time. So dark matter and dark energy, I think, will just be the influences of this Markovian dynamics that aren't seen directly in terms of particles, but that are seen. And I can go into the mathematics of it a little bit deeper. What's going on is we have a deep Markov chain, and projections are trace chains. You take a subset of states and you look at the Markovian kernel, only what happens on those little states, and you get a new little Markovian kernel on just those states. We call it a trace. So they have a big Markov dynamics, and we trace it on a subset of states. Well, so if all you're seeing is the Markovian dynamics on this little set of states, they're being influenced by all of the dynamics on the other states that you don't see, but because you don't see them, they're dark. So dark matter and dark energy, I think we're going to come out of this trace chain process. We'll actually be able to show from our deeper kernel and then the trace kernel that it's the properties of the kernel that aren't being traced directly that are responsible for the dark matter and dark energy kinds of things. So yes, I'm looking forward to that.
Do you have time for me to share a short story and get Don's comments on it?
Yeah, please.
So, when Stephen Hawking had his 70th birthday, I had written a book with his co-author, Leonard Malodno, and they flew Stephen to New York to celebrate his birthday along with his wheelchair and his computer and everything else. And at the Lincoln Center, they had a ballet performance. And the ballet was called was called Icarus. And the story is that there's this huge spaceship, as big as a city, with a huge number of human beings. And it would take multiple generations to get to another galaxy. And the captain of the ship had a son who was 12 years old, and his name was Icarus. And as they were going through intergalactic space, the captain said to his son, "Hey, listen, boy, we're going to be going around black holes, and be careful, don't mess with them." Of course, Icarus, 12 years old, when you tell somebody not to do something, they obviously will do it. So when everybody was asleep, he got to a little, like the spaceship had little spaceships, like a big ship has little boats. And he took this little spaceship, messed with the computers, and he left the spaceship in the direction of the black hole. And then he skirted the event horizon like 2 or 3 times. And it was kind of a very, very precise thing he had to do with his computations, so he didn't fall across the black hole. And then he skirted the whole, the event horizon twice or 3 times, and then he got out of the gravitational field with his computations. And then he said, "Dad," he radio signaled his dad, "Dad, I did it. I did it." No answer. "Dad, I did it. I did it." He was screaming and he was feeling abandoned, and finally gave up. And so the little spaceship drifted off in interstellar space, lost. And then suddenly he saw another planet in another galaxy. And he steered his little spaceship and landed on this planet. And the inhabitants of the planet curiously came to look at the spaceship, and he got out. They said, "Where did you get that spaceship from?" He says, "It's my dad's." "Yeah, but that model went out of fashion a few million years ago." No, that was the play.
Right.
And, basically addresses your whole theory that space-time is doomed, in the sense it's another symbolic representation of whatever this fundamental reality is.
I love that story, Deepak. I have a question that I'm curious about, and I trust minds like you and Don more than my own on this. I had a thought as you were sharing that story. Is there any possibility in Don's paper, he talks about how not all conscious agents project into space-time. Did I get that right, Don? So there's a vast amount of conscious agents that are not existing in space-time.
Right.
As a theory, is it possible that dark matter is actually all of the conscious agents that can't be measured outside of space-time that's showing up as something that would just suck you in because there's no way to measure it? I don't know. It was just a random thought I had as Deepak shared the story.
Well, I think that's exactly the direction for us to look, that all these agents that are not directly being traced into space-time are going to influence the dynamics that we see inside space-time, but we won't be able to see them directly. We'll only see their influence. And so I think that that's a great source for dark energy and dark matter. Absolutely. That's in fact the direction I'm planning to go. I should mention that physicists have found these static structures beyond space-time, and we plan to write a paper at some point for a physics journal. And we won't talk about this Markovian dynamics. We won't talk about conscious agents. We'll just talk about entities beyond space-time. So there's Markovian. So we don't need to say what these entities are. We can just write down the mathematics. There are some entities beyond space-time. This is their dynamics. And when we do this, we get spin, momentum, all the stuff inside space-time. And we can do all these neat things. We get the amplitude-hedron. That's going to be what the paper would be about. But we're going to all have an issue. These are entities beyond space-time. If you don't like consciousness, there's nothing that you can put there that's comfortable, because these are all entities not inside space-time. So physicalism is going to be dead anyway. And I'm happy for people to have other proposals besides consciousness. I can't think of one right now myself, but I'd be happy for someone to come up with a different proposal. We'll see.
Are conscious agents dimensionless?
Yes, because they're not inside space-time. So that's right. So they don't have a.
Therefore, they're infinite or timeless.
Yes, they're timeless, and I should say something really interesting about that. A Markovian, someone might say, look, a Markovian dynamics has a step sequence in it. So isn't that time? And what do you mean it's timeless? So there's a specific technical answer to that. Yes, there is a dynamics, and so there is a sequence of states. But you can easily design a Markovian dynamics in which the entropy does not increase with the sequence. So there's not an increasing entropy sequence. So it's timeless in the sense that there's no arrow of time. There's no entropic arrow of time. But it's a theorem that if you take any such dynamics where there's no arrow of time, and you take a projection, so you're losing information about the Markovian dynamics. So I think space-time is a projection, for example. It's a theorem that when you take that projection, the new dynamics will have increasing entropy. There will be an arrow of time. So my view is time, as we perceive it, is not an insight into the nature of reality. It's entirely an artifact of loss of information from the projection. So it's an illusion. It's an illusion of the projection, and time is an illusion. But that's now it's a theorem. It's not just a hand wave. That's a theorem of the mathematics.
Jennifer, if you have any question, because I have one last question.
Yeah, I have one last question as well. Twice in the last few months, one after reading your article, something came up, and once before that in a meditative state, something came up. I am curious how love factors into all of this. In the first instance where this came up about a month or two ago, I was shown the universe again and the expanding of the universe and all of the pain of the universe, and how love was like the equivalent of kintsugi gold that was meant to flow through the cracks in the universe to repair all of the pain and the suffering. And then recently, when I was meditating on your article, Don, just to ask what sort of questions, I had an interesting insight. So in the article, you talk about gluons and quarks and how they're really the building blocks, of course, of protons and neutrons, and how the quarks themselves then are kind of connected via the gluons, if I understood that correctly. Is that right, Don? Mm-hmm. So then, and again, this was totally a wild theory. I'm just putting it to you because you're brilliant, and Deepak, of course, as well. What are the odds that love is somehow or another tied into all of this as it relates to consciousness? Because I haven't heard any of us talk about love, and yet that too seems to be fundamental in some ways to the universe. I don't know, obviously not to maybe plants and animals, but to the human experience.
Well, I think that there is a deep connection here in the sense that, in some sense, the deepest notion of love is to recognize, it's not that you just love your neighbor as yourself, but you recognize that in some sense your neighbor is yourself. That that's right. That the way you treat your neighbor is the way you're treating yourself, because your neighbor is yourself. And when we think of that, all these little conscious agents that we see inside space-time are projections of the one conscious agent that perfectly aligns. And so in some sense, when we wake up and learn to love our neighbor as ourselves, what we're really learning is we're waking up to who we are. I am my neighbor. And so the way I treat my neighbor is the way I'm treating myself. And that's part of the whole waking up process. So I agree.
Thank you, Don. I love that you guys let me ask these fun questions. Thank you.
So Tagore, the Indian poet, said, love is not a sentiment or an emotion. It's the ultimate truth at the heart of creation, unity consciousness. Yeah. So my last question is the following, and then I think we need to wrap up because we have 1 hour limits on social media, at least on my channels, and I'd love to put this on my channels too. So, recently the conversation around artificial intelligence and the idea that AI could become conscious. And I never thought that AI could become conscious. And then I came across these terms in AI. One term is perplexity and the other is entropy. And these are technical terms. So perplexity is a term that defines what they call certainty, and entropy is a term that defines uncertainty. And why AI could never become conscious is most AI systems are based on algorithms that predict outcomes. For example, when I'm typing a text message and I say, Don, can we have, it automatically gives me choices, dinner, lunch. And if I say tomorrow, it says, today or tomorrow, whatever, but it gives me a few choices. And it actually tries to guess what I'm saying. And that is perplexity. On the other hand, entropy is uncertainty. And the hallmark of consciousness is actually uncertainty, because uncertainty and creativity go together. And therefore, I think an AI could never be conscious or creative in the true sense of the word. I just like your comments on that.
Well, the way people are typically asking that question, could AI be conscious, is a physicalist framework. So they're saying, we assume that space-time is fundamental, that there are these particles, protons, neutrons, electrons, and atoms, and so forth, that are, of course, unconscious. They're just physical. But the question that they have in mind is, could we get them organized in such a complicated enough way that they have the right functions, that somehow consciousness somehow emerges? And that whole framework is hopeless. So the very way that they frame that question is wrong, because space-time is doomed. Space-time is not fundamental. So the way that question about AI, could AI become conscious, is a physicalist question that has the wrong foundation. And it's just the answer is that you've asked the wrong question. There is no answer to that question, because space-time is not fundamental, and consciousness does not arise from unconscious ingredients. Consciousness is fundamental, and it gives rise to what we appear to have as unconscious ingredients, as a projection of its deeper reality. So that whole way of thinking about things is just wrong-headed from you, because it's physical.
Which is another very interesting premise in the Eastern wisdom traditions. Only consciousness can be conscious. You as a body mind are not conscious. You are an experience in consciousness, a symbolic representation in consciousness. And that fundamental consciousness is irreducible and therefore incomprehensible.
That's right. So I'll change the question a little bit then. I'll just say, look, from the point of view in which consciousness is fundamental, as you were just saying, we can think of it this way. Your body is a portal into a consciousness, right? So I see Deepak, I see Jennifer, I see your body. That body is an icon in my headset that gives me access to your consciousness. So the right question is, could we develop new technologies that might look like artificial intelligence, that could open new portals into pre-existing consciousnesses? In other words, right now we have one technology for opening new portals. It's called having kids. That's how we open new portals into consciousness. Can we reverse engineer that and have new ways of opening new portals into consciousness? And my answer is, I think yes, and it may look like artificial intelligence, but it won't be unconscious ingredients giving rise to consciousness. It will be consciousness using its interface to open up new portals into consciousness, a completely different way of thinking about it.
Oh, guys, this was my favorite interview that we've ever done together. Just like I told you, Don, as we got started, this is my favorite thing that you've ever written. So we can't wait to be able to share Donald Hoffman's paper, which is coming out in June 24th, I believe, through IONS, that you'll be able to look out for that. And we also invite you to join Deepak and myself on July 15th at the Global Woman event in London. We'll both be speaking there. And hopefully we'll all be able to do an in-person panel again. I know we've done one or two of those, so it'd be great to be back in person, and always in conversation. So thank you so much to everybody for tuning in and playing with us in this quantum field of consciousness.